Hello guys and welcome to 737 DIY Sim here in the UK. Now a very different episode, not 737 related whatsoever. And this video in all honesty has been 5 years in the making. And today, this is the first video of 3. We're going to concentrate on the helicopter controls. Now, as most of you know, if you don't know, I'm a helicopter engineer and have been now for almost 30 years. So I've got a good understanding of how these controls work. These controls have also been backed up by many pilots. In fact, the collective that we're about to build today has been worked in conjunction in the last 5 years with a guy called Woelke in Brunei. And he guided me on how it should feel on the 139. Here we are sat in my sim. We've got the Cessna instrument panel and I've got the displays loaded up on that. We're in the gimbal aircraft, rotary aircraft, and in front of me here is the cyclic. To my left is the collective. Now, if I give you a quick demo, I'm going to switch the force trim on. So if I move the cyclic, with the trim on, it always returns back to the center place where you left it. And that place can be any place where you leave it and you reset the trim, which is what the little red button on the side is for. It's the same for the collective. You can see that I'm pulling power in, but it returns always back to the place that you left it, and you're having to fight it. There's a lot of force there in the collective, but if I hold the force trim button in, now it's really easy. It takes no force whatsoever, and we've now got control of the aircraft. So, this video is not how to fly, because I am not a pilot. I've got all the settings set to the hardest level. In fact, you may be able to hear the collective lever moving. And what I'm not going to demonstrate in this video is I've actually got the autopilot hooked up to the collective. So it's trying to, when the autopilot's engaged, it's trying to drive the collective up and down. We're not going to use that. And for my first takeoff, I'm actually going to switch the force trim off. So the controls are completely floppy. And if I didn't hold them, the aircraft would just fall over. But it makes it a lot easier trying to hover. Here we go. So I'm going to pull a bit of collective in. I'm going to put a bit of right pedal in. And we're up. I'm going too much right pedal, but let's spin around a bit. I'm going backwards, which is good because I've got that aircraft to the right of me. We're dropping. And a bit of left pedal to turn around. And we're out to the taxiway, lowering the collective down slightly. Okay, so force trim is completely out and we're heading down the taxiway. A bit of left pedal. And can I get it to spin round without losing control? Here we go. This is definitely a tongue out of mouth type moment. Oh, geez. I've just done a 180. Okay, come on. Let's get it back under control. This is what's so satisfying about this sim, is that it's not easy to fly and you can easily lose control so quickly. Here we go. So we're getting into a kind of stable hover, taking it nice and gentle. Oh, that's nice. A bit of right pedal just to straighten me up, and we should. The problem is if I put a bit of right pedal in, it affects the collective and the cyclic, and that's when things start to get a bit difficult. By the way, I am no pro. So we are actually, by some miracle, on the runway and we're losing height rapidly. I'm finding it very hard to talk, look at the camera and fly at the same time, being a complete beginner. Oh my gosh, we're going in hard. A bit of right pedal, come on, can we recover it? Okay, so we're about 50 feet in the air here, and now we're into a nice roll. But hopefully you can see how the controls are working. And of course, we're quite high up here. Let me get you down the runway again. Let's get lined up. Let's see if I can get a bit more control in here. That's better. So a bit more control. We're going way down to, there we go, put a bit of power in. So going up, it's right pedal in. Going down, it's left pedal in. There we go. Right, come on. At the moment, the force trim is still out because, you know, I'm trying not to over-exaggerate the movements here. Oh, wow, that wasn't good. We just dropped like a stone. Okay, come on. what I'm going to do is I'm going to base this down on the floor. I'm going to go hard left. Come on. I think I've damaged the aircraft because we are not going back to... There we go. Right. We're down. Very undignified landing there. Here we go again. So now I'm going to try and hover taxi back to the heli spot. Bit of power in, a bit of right pedal. Just dropping the collector slightly. There we go. Bit of left pedal now to spin us round. Okay, it's a little bit more controlled. And okay, so we're slowly heading down the runway, but very straight. We're kind of crabbing. There we go. Come on, spin me round, get me forward speed up. Of course, actually flying the helicopter with a bit of forward speed above 30 knots is relatively easy. It keeps nice and steady, straight and level. And that's really when you can engage the trim. So if I engage the force trim now, and now I can let go of the controls, and the aircraft is doing what it's supposed to do. I can hear the autopilot taking over, trying to keep it level and straight, which is ideal. Look, I'm hands off now, and it's doing its job. I don't know if you can hear the clicking there. That's me releasing the force trim on and off just to show you. Okay, so we're coming down a bit fast here. So the force trim is fully engaged now. I haven't got my finger on the button, but moving the collective. Oh, there's the autopilot coming in. Oh, I have to say, it actually feels it's a lot easier to control with the force trim in. However, I think that's because you can hear the autopilot kicking in and trying to keep it. That's the SAS system of the autopilot, and that is the Stability Augmentation System, SAS, is keeping the aircraft straight and level for me. So it's cheating really. That's why I've not been flying with it in, but it's definitely keeping the helicopter a lot more level. In fact, you can see, look, with very little movement on the cyclic, it's pretty much looking after the aircraft for us. And if I'm going to let go of the collective, there we go. Let go of the cyclic, sorry. There's the external view. Come on. And drop in. It's actually a bit easier to fly it from the external view because you can see the angle of the helicopter. You can see the angle of the helicopter. There we go. We're going down the runway. And I really do like flying at a 45-degree crab for some reason. I don't know why. Here we go. Come on, we'll get down the taxiway. The problem is I can lose control so quickly. There's the heli spot in front of us. I'm going to switch back to the other view so I can see it. Pull a bit of collective in now. I'm really fighting the collective. Woo. I'm just releasing the trim and we're down. Okay guys, enough of me trying to fly. Let's get into the build video. Let's do this, guys. This is an awesome build. Got my laptop to the left here, and that's just going to help me guide through the build to make sure I get the right size screws that I can point out in the video. We're going to start with a force field unit. Now this was created in two parts. We've got the center support, and then we've got the force field gear. And they're in two parts, so you didn't have all that support material underneath. And these should just slot together, just making sure I get the orientation the right way round. Are the screw holes lined up? Yes, they are. And we're just going to push those together. Then we've got some M4 by 14mm screws, and they're just going to hold the gear together. Next up, we've got the center support, and that's going to go in the blank space here. So it's going to line the holes up over the top and put some M4 by 8mm screws into the base of it. There we go. We can actually turn it over now, and there's a single screw that needs to go in the back here. That's an M4 by 10mm, and that's those 3 bits completely assembled. Now we've got the force field tongs, and they need 608 bearings in, 2 of, and these are just your standard skater board bearings, really cheap, but they help take the load and make the operation a lot smoother. So in they go. Nice tight fit. They slide over the spindles there, the shafts, and now we need the top cover. Just removing the support from the inside of the print, there we go. And this should flip over and sit in place like it does there. And then we need some more screws. And again, these are M4 by 14mm screws. Next up are 2 6203 bearings. 6203 is the number, and they just push in top and bottom. There we go, tight fit. Now next up are the springs that go on the force field unit, and we need to create an assembly with that. So we've got a M4 by 40mm screw and an M4 nut. Just going to screw it on. Going to leave a little gap at the top. Going to put it through the first tongue, flip it over, put another M4 nut on, give it a little tighten. That lock nut is just to secure the spring to stop it from coming off, and then we need to do the same again for the bottom tongue. So that goes in there. Now these springs set the tension of the unit, and these are from an Amazon assorted spring box. We'll come back to these spring tensions later on when we come to set the unit up, because it's quite important. These may not be the right size, and I might need to get some bigger ones. But at the moment, they just fit over the 2 ends of the nuts. We're going to turn it over and repeat for the other side. And that will create our force feedback. There we go. And that, guys, is the first unit completed. Put that to one side. Next up is the cooling fan for the stepper motor on this unit. Now this is really important. It really helps keep the stepper motor cool because you're constantly driving current through it to hold the trim in the right place. I've bought these cheap 24 volt fans from Amazon, and they do the job really well. I'm going to put the cable going downwards. I've got some M3 screws, and they're 16mm long. I need to change my bit over. There we go, eject it there. Put a new one in, and we're just going to drive those screws home. 1. 4. Going to grab the left hand side, and we're going to mount this to the unit. Just going to put it on top so it's facing outwards. Flip it over. The screws for this are M4 by 20mm, and all these sizes can be found in the build guide anyway, which is online. Just going to put that to one side for a second while we now create the stepper motor. So what we want to make sure now is that the stepper motor connector is facing down, so it'll be towards me, and on the stepper mounting plate is an arrow, and that needs to point up. So that's going to face up, the connector's facing down, so they face away from each other. We've got some M3 screws to go and hold these two parts together. We're going to feed the stepper motor through the unit. I didn't realise these are the same colour, hope they show on camera. So that's better, at least the mounting plate's grey, so you can see the contrast. Now these are M4 by 20mm screws. Now, yes, so hopefully you can see that the stepper motor moves backwards and forwards, and that's for correct meshing of the gears later on. We now need the spur gear to go on the shaft. There we go, just pushes on like that, nice and simple. We need a 6203 bearing in the top piece. Yeah. And then we need to put the side support on. This is the side support that helps make the unit a bit sturdier. It's just going to slide into the recess there, flip it over, And we've got two M4 by 20mm screws to hold it in place. And I believe that is the left hand side done. Very simple. Next up we've got the Hall sensor, and a lot of people wanted Hall sensors over the cheap pots. I've never noticed a difference, but apparently you guys can tell. So we've got our Hall sensor, the sliding plate's going to go on. We've got our M2 screw, and hopefully we'll get that to locate in one of the holes. Feels good. Yep. These screws are tiny and my big thumbs get right in the way. This is the right hand side, and hopefully you can see it's got right hand side written on it. Place the Hall sensor through the slot and the mount over the top, and we're going to attach it with M4 by 14mm screws. There we go, there's one. Once again, I'm hoping that moves backwards and forwards. It needs to be 3 so you can again align the gear meshing. The next part is the spur gear for the Hall pot. Looking for the flat spot on the unit. Going to give it a bit of tappy. There we go. On and secure. There's no stress on this gear. It's just taking the Hall sensor reading. We've got another 6203 bearing. That's just going to push into the right hand side frame. All we've got to do now on the right hand side is fit the support. Again, just going to turn it over. We've got two M4 by 20mm screws. We'll drive these home. And that's all 3 parts complete. Now it's time to build the actual collective lever assembly. First off, we've got the pole base adapter. Now, originally this was designed like this. This is version 1. And I went to take it off the support here. And the other shaft sheared off. So it makes it completely useless. So I thought if that happens to me, it's likely to happen to somebody else. So let's go for a redesign. So what I've done is I printed the pole base adapter, the PBA, so it lays down flat on the surface. And then the pole supports that were printed separately, that goes in that side, they then slide into the unit. Now, these pole base supports don't take really that much load because there's a steel bar that runs through the middle, and that's what takes the load. These are like shaft adapters. They take the 8mm bar or the 12mm bar and they adapt it to the bearing size of 17mm. Right, they can come out, put them to one side for a second, and we need our tube. So the collective lever was designed with a 25mm tube as the base diameter. Now, the version you saw earlier on the computer, that has got a stainless steel shower bar that you get off Amazon. They're really cheap, they're about £2.15 I think. Whereas I went for a PVC one this time because this is going to be a lot easier to work with, and it's still very strong. So I'm going to insert the tube into the base. I'm going to turn it on its side, and I'm going to use the small adapter. I'm going to push. I've got my 8mm drill bit to guide it through, and I'm going to drill through the tube like so. So this rod is going to help secure the pole base so it can't move and it can't pull out. So there we go. And that means we can now turn it upside down and drill the hole underneath. Now this bottom hole is where the wires come out. I'm going to change to a step drill because I'm hoping this is going to do a better job. It's quite a big hole. So next up we need some 8mm threaded rod. We're going to put a lock nut on one end. So we've got our lock nut on the end of the threaded rod. We've got our 608 bearing, again skater bearing, in it goes. We've got a standard 8mm nut. And we're just going to thread that on all the way. 8mm washer. That's going to go through the base here, he says. There it goes. Another 8mm washer. And there's no way I am driving a lock nut all that way down. So now we'll mark it. Out comes Mr. Dremel, and time to make some noise. Let's see how that fits. Good through there. And hopefully, I'm just going to tighten this nut onto the unit. And that's what the bearing setup looks like. Free to rotate, but feels quite solid. On to the next part, and again, we need to create a spring lever. And it's exactly the same as before. We've got a M4 35mm bolt. We've got a nut, and we're just going to screw that on. Going to feed it through the unit like so. Put another nut on. Give it a little nip. Now this bolt deals with the counterbalance of the collective lever. So everybody's collective lever is going to be different, which means we're going to need different force springs depending on the weight of the lever. We'll come into this more later, but for the time being, that's what it should look like. Then we need one final nut, and I'm using a lock nut to make sure it doesn't come undone, just to secure it onto the end. Now we get to fit the collective tube into the base assembly. We're going to put the long side in opposite the gear, the short side in like so, and now we get to fit our first big assembly, which is the force field unit. And it goes with the flat side against the unit, and you've just got to make sure that you fit this bearing between the tongs in like that. Then we need our spacer, and next the left hand assembly. Oh, it's starting to get somewhere now. Just going to hold it to one side. On goes the right hand side. Brilliant. Just going to take the right hand side off a second and put a screw into this. It's going to be a lot easier to put this screw in now, and this screw is what adjusts the tension of the gearing. Like that. Perfect. Hopefully you can see it's starting to look like something now. Yep, that's going to go in there. We've got M4 by 20mm bolts. Now this is the base. This part in the middle is the collective lever stop at the maximum end, and we need to put this in. And again, it's going to be a lot easier if we do it now with all the bits are in. Like so. And that is it's supposed to be an M4 by 40mm. I've changed it for an M4 by 50, so it's really easy to reach from the outside. And all we're going to do is orientate the assembly to the correct way round. Perfect. We're just going to nail it up with M4 20mm screws. Now you may notice that I've not put all the screws in. That's because I've already got one of these and it's fully built. This is for just demonstration purposes, and once this video's done, it'll be coming back apart and the plastic off for recycling. So I don't need two of them. The collective unit was designed to have 60 degrees worth of travel, and that can be shortened by adjusting this screw here in, which will stop it from going up any higher. There's also an 8mm bolt that can go in here, which will set the height of the unit here. And I think we'll put that in now. I'll leave it at that at the moment. It looks about right, just slightly up. But you can go it all the way horizontal if you want, depending on how your seating arrangement is. Next up is to put the 8mm bar through the centre, and that's what takes all the load. Then we've got our caps. They just go left and right. 2 8mm washers left and right. And then our lock nuts. Oh, brilliant. I like to cut my 8mm bars slightly longer than what it states in the guide. That means we can get the sizing perfect. It's always better to have them too long than too short. As you can see, we've got a whole 12mm that needs to come off here to make it look smart. We'll do that with a Dremel now. So we're nearly completing the base unit now, and you can feel it. It's starting to feel amazing as it is. We need another 8mm rod. Once again, just going to put a washer on. Going to put a lock nut on one end. We're going to feed it through the base here. Add 2 springs. Feed it through the other side. Oh, there's a washer there. That's perfect. And the other 8mm lock nut. And then all we have to do is hook the springs onto the back of the collective pole base adapter. They just hook over like that. And it should look something like that. And what they're going to do is they're going to stretch and help just take some of the load off the collective. At the moment they're not really needed because there's not that much weight, it's just a plastic pole. But when you've got the whole head and the throttle assembly on, that really adds up. That's the base unit done. Next we want to do the throttle assembly. Now this is not included in the base pack, but I thought I'd show it anyway because it'll be a handy build guide to have. And there's no point doing a separate video just on these 4 pieces. 1, 2, 3, 4, 5 pieces. And the reason why this is not included in the base pack is because there's not many aircraft anymore with manual throttles. However, there are a few in DCS and other programs like Xplane that do require a manual throttle. We're going to build one. You can put these back to back and have twin engine throttles. But for the time being, we need to fit some brass inserts into the units here. I'll balance the brass insert into the hole, into the orifice. All we're going to do is feed the soldering iron into the hole. There we go, that's one done. I'm going to put the other brass insert into the hole. Try and feed the soldering iron through. I'm going to take it just below the surface. There we go. So hopefully it mounts around it. That's the first unit done. Next up, we've got to fit our Hall sensor to the throttle base, and we're just going to line it up like so. And we've got 2 little M2 by 10mm screws. And once again, because they're so small, my big fingers struggle to get the screws in there. Come on, in you go. We've got our spur gear that's going to go onto the shaft. If I can find it, yeah. Just going to align the flat faces. There's our spur gear into the recess. All we've got to do now is feed the throttle base onto the shaft. If I turn this upside down, it might be a lot easier for you guys to see. I'm going to feed the clamp now underneath the Hall sensor. I've got 2 M4x20 screws. And we're going to screw those down and clamp them on to the shaft. Just trying to pull them down so they're even. Then I'm going to make sure that the Hall sensor is facing downwards exactly, or as best as I can, and the joint in the clamp is horizontal. We've got our twist grip, and that is just going to feed into the unit. On goes our throttle cap. And this cap has got the stop-in that restricts it to 180 degrees movement. So again, that goes at the top. The clamp will go at the bottom. Yep. Okay, that feels good already. Going to put the base clamp on. That's it. And now you can see that we've got the throttle base here with the Hall sensor, and we can twist it 180 degrees and back, and it's all controlled by the Hall sensor. We'll add the wires in later. And the last part of the twist throttle is just to put the cap on to hide the gears. And of course, you wouldn't print these in multicolours. Once again, this is just to show it easily on camera. Now I think this throttle unit looks amazing on the real one, where it's printed in black with a grey throttle. So I'm just screwing the cap on now, and these are two M3 screws. They're 10mm long, but it just adds to that finishing look. Now I'm thinking that's looking pretty cool. There's our twist grip, 180 degrees. So that would be ground idle, flight idle. But you can see the trim is also coming into effect. So that's force feel. I'm actually holding the big spur gear here, and that's the job of the stepper motor. But we've also got a good action with the stepper motor. Let's do the gear meshing of the stepper motor, and that's done with an M4 by 40mm screw. And we're just going to feed that screw into the front. And that's going to push against the stepper motor and drive it towards it. Not too much, but you can see that it's fully engaged now. And we're going to do the same for the Hall sensor pot. And hopefully this bit's going to fit through the hole. Yes, it is. And drive there. So now when I move the collective, hopefully you're never going to see that because it's too dark in there. But now it's driving the Hall sensor around. Now we get to put this to one side, and we get to build the 139 collective grip. Now this grip is in two halves. It's already been assembled to keep it together, because if you don't do that and you leave them in two halves over a period of time, the resin warps. So I found if you screw them together straight away, that prevents them from warping and keeps them in the correct shape. Just want to make sure that I've got the right size bit here, and we're going to take them apart. Oh, it's already coming apart with my fingers. There's one. So hopefully now that all the screws are out, this is going to separate. There it goes. Into two halves. And that's what the centre looks like. As you can see, I've put the brass inserts already. They're just super glued in. And we need to create the buttons that fit in these two holes here. And we do that with our little tactile push buttons. We fit them into the base. And this one here has got the shape of the nut in it. And we just spin it round. And it's done. We've got the little button cap to go on. It's red, and it actually should be red, I believe. We're just going to push the button assembly into the left-hand grip. There we go. It just sticks out ever so slightly. And we're going to secure it with two M3 screws. Moving on to the forward button here, we're going to put the push button into the case again, put the nut on, and this one sits below the surface. You actually have to make a positive feel with your finger to be able to press it. Give that a quick squeeze. So next up we've got the trigger. Now this trigger is going to be used to release the mag brake on the collective lever. So it'll make the controls go nice and soft and makes them easy to move. Okay, I'm just making sure that I don't do it up too tight so it binds, so it's free to move. We've got our micro switch, which is going to disconnect the stepper motor. And these are this is an ultra mini micro switch and two M2 by 10mm screws. And once again, because these holes are new, finding them is, there we go. Hopefully that's the correct place for the switch. Oh, that feels much better. And because the trigger feels a bit soft, I'm going to add a big juicy spring behind it. And that's just going to sit in there. And with the spring there, that just feels so much better. So we're onto the wiring, and the first thing I'm going to tell you is I'm currently not going to wire the two button switches up, even though they're fitted and they're fully operational. It's because the sim doesn't utilise them yet. And it's just like the remainder of these buttons on the face panel that we're about to create. There's very few ones that we can actually use. Now we need the collective trim, which is this top hat here. It's missing the top hat because I've been playing with it. And let's just put it on so you get to see what I'm talking about. So we need the up and down, because that trims the collective up and down. Now if we had pedals, and they are coming, it's also got left and right, so you can trim the pedals left and right, hence the collective yaw interlink there. To the right, on the black top hat here, and again it's very hard to see on camera because it's black on black, it says landing light, and of course this would motor down where you can extend it and retract it in, and then you can turn it left and right. That actually might be possible on some of these sims available. However, I'm going to use that top hat for viewing POV, so being able to turn my view in the helicopter left and right, and that's quite important when you come into land and you want to look down through the chin windows. So I'm going to use the landing light for field of view, and I'm going to use the trim hat for the trim hat, which means I'm actually only currently going to connect these two buttons up and the trigger release here, which is the collective force trim release. I've got all my wires ready here that need to go into the collective. As you can imagine, this is a very small area to get all these wires through. And for the first time ever, I've got this from CPC Farnell. Absolutely amazing stuff. It's 28 gauge, it's really strong. I think it's aluminium wire, just like aircraft wire. It's also white. There's 500 meters there. 500 meters, good quality, for around 26 quid. I think it's about 29 quid now. That's 29 Great British pounds. Lengthwise, so I've said they're 28, and I highly recommend at least 2.5 meters. So this is 2.5 meters here. If you can afford to, I'd go to 3 meters, because you're going to go through the collective pole, you're going to go into the base unit, and then you need to go forward at least to the cyclic and the pedals to the Arduino board, where you need to connect it all up. So you need a fair bit of distance. And when I created the first version, I think I used about 2 meters, and that just wasn't enough. It's enough to make it work, but the cables are pretty taut, so an extra meter would give you plenty of playroom, wiggle room. Enough waffling. Right, I've got to connect 3 wires. In fact, I've been thinking about this in the tea break, and I'm actually going to connect 4 wires, because I don't want to run multiple grounds through these tiny holes. The collective is actually quite small on the 139 for the amount of buttons on there. And even though we're using 28 gauge wire, and that's quite thin, well, I think we're going to still get it through. So we are going to daisy chain the ground from that micro switch into the collective box. Okay, we are going to strip the ends. 1. I've got a short piece for the ground extension for the daisy chaining. Going to trim that. We'll do the ground first, so we'll take our long cable, we'll twist these wires together. Now, will I fit a piece of heat shrink over 2 wires? Yep, this is 2mm heat shrink. We'll tin the wires. There we go. And we'll also tin the 3 connections on the micro switch. Right, I'm also going to tell you that I'm going to connect all 3 connections to the micro switch. That's the NO, normally open, normally closed, NC, and the COM. COM being the middle one. No, it's not. It's a good job this is labelled. The COM is the far right in the picture here. And the reason I'm doing that is because I don't want to open this back up if I want to change the wiring configuration of the micro switch. There we go, that's that one done. And we can actually take the ground wire and feed it into the first tunnel. There we go, so that's going to loop round and into the collective box at the front. This side is going to go back through the unit, through the tube and out to the Arduino. We need 2 more connections on there. That's these 2 wires. Put a bit of heat shrink on, make it look pretty. We'll move the heat shrink down. We'll feed them down, and that is that side done. We can now put the top on, and that is the collective grip, looking pretty awesome. There's our trigger for the collective release. Now we've got to fit the collective box, and this is the collective box. Because this is a resin print, I'm going to pre-tap the holes. I'm not going to lie, I was taking that easy. Resin can be quite brittle and I did not want to break that at this point. There we go, get rid of the crap. So once again, I'm going to feed my cable through the hole. Let's get through the right hole, the cable magnets hole. We're going to put them together. I'm going to need some screws. So I've got some M4 screws, and these are going to be a bit tricky because of the angle they have to go in at. So let's put them all the way through to start with. There we go. I'm going to pull that out, put another one in. And there we have our collective grip base, or base assembly at least. Got a big channel here for the remainder of the wires, and that's what we need to get the wires through. But first of all, we need to build the faceplate. Once again, we can put that to the side and move on to the next part. Let's do our toggle switches first, and these are really simple. I'm just going to undo the nuts there, find out which way is top, so the 2 together. So these 2 holes are facing the top, the 2 that are close together. And we want to put the recessed line here facing upwards, and then we want to put our nut on. And I've got a 14mm socket here, and we're just going to tighten them down, he says. Yep, yes we are. So now it's time to do that again, but this time with a single switch, and I believe this is the RPM switch, and we're just going to screw the nut on the top, hopefully. Nice and tight. Good. We're going to put our switches into the base plate, and they go in really simple. And there's 4 of these that go into the base plate here to hold these 4 switches in. Now we're going to put the single switch into the unit and secure that with a couple of screws. Next up, we've got 4 fake screws that go in to these 2 points here, and these are just to make it look good and make it look exactly like the real thing. Next up are our navigation switches. They just slide in the back, and we just rotate them so that we can fit the support brace across the back. There's our navigation switches in. We need our 2 press buttons here. They're going to slide through the front, and we can just put the nuts on from the rear. Really easy. And remember, you can use these buttons for anything that you need. And if your sim supports the 139, then you're laughing, you can connect them all up. Then we've got 3 more push buttons that go in the outer holes here. So we've got the green on the left here. All that's left are the 3 mini toggle switches that go in the base. Yep, there's one. Now these are momentary toggle switches, so they always return to center. And that is all the hardware in the collective base plate. We can now fit the laser etch faceplate, give it a little dust off because it's been there a while, and that should fit over the top into the exact place. Now we can fit our security caps, one there, one there. We've got some laser etched decals to go in there, and they should pop in with quite a nice push fit. Yeah. Next we can fit our top hats. So it's the black one on the landing gear, which is the right hand side. Oh yeah. And then we've got the rounded grey one that goes on the left hand side, the collective trim. Perfect. They're all functioning well. To fit these caps we need some M3 grub screws. And we've got the red ones that go in these positions here. Okay. I'm really smiling because I love how it looks. There is our 139 collective faceplate. Right, that's all the labels created for the cables. Bring in the unit. I've got the wiring diagram here, and all we've got to do is line the pins up. You've just got to remember that that is looking forward on it, so it's looking from it that direction, so everything is back to front as we turn it over. Now this is the wiring loom that needs to go through the handle, and I think it'd be a really good idea if we did that now before we put the cable idents on, because that's going to make the loom so much bigger. That's them coming through the handle. Let's wire up the daisy chained ground. So we're going to need to bring this one in a bit closer. I need to strip this end here. Twist 2 wires together. Put a piece of heat shrink on. And again, pre-tinning the wire. There we go. So in we go. And all we've got to do is connect that daisy chain ground to the other unit. Bring the heat shrink back over and nail it down. There we go. And as I said before, we're not going to bother connecting all the buttons up because I don't really need them right now. This is just a demo piece. But if you did need more buttons, then you'd have to add more wires. So if we flip it over, we can see that the grey one here is the beep, which is on the right hand side here. That's called the beep trim, and that electronically beeps with the switch, beeps the collective lever up and down, like that. Well, not with my hand, but using the stepper motor. Okay, let's get these connected up. Need some more heat shrink. So now I appreciate that was probably quite hard to see on camera because it's so small. And you can see that we've got the ground here that's daisy chained. We've got the up button here and we've got the down button here. And on this one we've got to connect 4 more wires. That's all our cables connected. All I've got to do now is put the cable idents on the other end, and I'm going to do that quite simply by finding the cable. There we go. I can see it pulling through, and we're just going to grab the other end. There it is. So that's beep up. We've got our beep up ident. On it goes. All our cable idents are done. They're all heat shrinked. Let's see if we can get these cables into some kind of order. Pull in a bit of slack. With the wires all connected, bit of lacing cord just to tidy it up inside the collective box, and then we can run these cables through the collective tube. Now you can see that's quite a bit of cable that I've left out there, and that's so that if you ever need to come back into this unit, if you were to make this as short as possible and pull those cables all the way through, and this happens in real life on the aircraft, people think it's a lot tidier if they connect the wires up and pull all the excess through, but that makes any maintenance in the future completely impossible or extremely difficult. Now if you leave a nice length of it available so you can wrap it up inside the unit, and then when you pull it back out, the cable's not too taut and you can pull it all the way out and service the item. So that's why there's a little bit of excess there, which means we get full access to the back of the unit, and we can add any more wires if we need to, or even change a component nice and easily. So we're just going to fold those up in there, put the lid on, and put our final 3 M4 screws in to hold the collective box together. And here we've got our collective grip and box assembly. Now this is probably one of the better looking units I've ever created. I really like how it looks. The only letdown is that until the 139 sim comes along, half these buttons aren't going to work for their correct purpose. It's now time to put the collective box onto the collective lever, and to get this loom through, we're going to lift the collective up into its highest position. Just going to feed one single cable from underneath through the collective base in the hole, and that should come out of this end here. Eventually, there we go. We can put it up the right way. Just got some green frog tape here, and we're going to secure the cables all together. There we go. I'm going to bring in my other cable, one wrap around, back on itself, and another wrap around, and then just tie off. Now they're connected, we're just going to bring it through. Give it a little tug. Just tidying the cables up a bit by pulling them all through equally. When you put the collective grip on, it needs to be 15 degrees towards the pilot. So about that, it's not horizontal. In the real aircraft, it is tilted to the left, to the right actually, towards the pilot. Okay, we've got to drill a hole now for the M5 bolt here, and that will secure the unit in. Be very careful when you drill through that you don't cut into those wires. Now let's see if I can drill through this collective lever without cutting all my cables. My plan is to drill one side only, turn it round, and then drill the other side. Spinning it round, and then we're going to drill from the other side. Going to fit our 5mm Allen key bolt. No problem getting it through. And then we've got our nut this side, and that should sit into the recess. Just going to tighten the bolt up. Done. Yeah, that feels rock solid. And I can see that we've actually got a few issues with the balance and the setup of the force field unit. We'll get that sorted in a minute, because that's not right, and that's not exactly how the aircraft works, so we need to get back to that. And that's just because the springs aren't strong enough, which is why I put any kind of spring on to start with, knowing full well I'm probably going to have to adjust it later on. So now the collective grip is on and attached and it's pretty firm. We can move the twist grip into position by sliding it up against the collective grip, so there's no gap. That's good. And I've got my Allen key here. I'm just gently going to tighten it up so it doesn't move. And if we twist the twist throttle, it shouldn't move because that's where the stop is. So if it's too loose, that will spin, and it's not. That looks pretty good. Gently just going to tighten up the rear clamp as well so that doesn't move. Give it a tweak. Yeah, that's trying to twist the whole body. Now we need to tidy up the wires. Off camera, I attached the 3 hall sensor wires, but I want to put a bit of sheathing on them to hide them, to make it look black so it blends in with the colours, but it would do on the real thing. And just going to join these 3 cables together with a bit of frog tape, and that's just so I can feed it through the cable sheathing. Okay, I'm just going to feed it in. There it goes. It takes a little bit of time, but it does go through quite easily. I'm just going to feed that cable sheathing around, and we can put a bit of lacing cord just to secure it against the hall sensor. Slide it into position. Granny knot it at the end. Normally you do a double granny knot, but as this is just a sim and not real aircraft, that's more than enough. And I think we'll just add some lacing cord now onto the main tube. My original plan was to feed it through the tube, but it would have been much easier to do that before I put the other cables in. This will work just as well. We'll trim those ends. I've got both ends of both looms. I'm going to join them together and then put them through another piece of larger cable sheathing. So you've just got one loom coming from the unit. We're just going to tie off the end to stop it from fraying, and we'll lace it at the end here. Another granny knot to secure the other knot. Give it a trim. And that is the wiring loom finished, ready for video 3. So putting it in the black sheathing just makes it look a little bit tidier. Before we can end this video, we've now got to do the collective balancing, because it shouldn't do that. If we put the collective lever in a raised position and we let go, not only does the whole unit move down and the tongs move up. So the tongs, the springs on the tongs, aren't tight enough, they're not strong enough to support the weight of the collective lever. So we need to correct them first. In fact, feeling them, they feel really weak. So we've got my Amazon all sorted spring selection boxes, and what we're going to do is we're going to change some springs over until these tongs do not open when we move the collective lever. So that's quite a big one on there now. Let's put it in a more upright position, and you can see, look, it's still moving, so that's no good. And what about that? Oh, that's got it. Okay, so you can instantly see now that when you move the collective lever up and down, those tongs do not move. It's the stepper motor moving, which is exactly what should happen. So if I lock the stepper motor off with my finger now, and I push down, that's when the tongs should open. And that's when you know you've got your force field correct. Okay? So now the tongs are staying with the big gear assembly. I'm going to pull the collective up and I'm going to let go, and you can see it goes down. So the springs at the back here, these are the counterbalance springs for the collective lever. They're not strong enough and they need to be changed for a stronger spring. So I need to take one off, and I'm going to try and find a spring that's just a little bit stronger than that. What about this one? Oh yeah, that feels good. In fact, I'll take two of them. I won't do the nut up yet, but we'll do another functional check. So I'm going to lift the collective lever up. Still a bit heavy. Okay, so we need stronger springs. So we've got these two springs here that aren't strong enough. We've got this one here. It's an 8mm spring. Okay, let's give that a go. Just going to hook it onto the eye. Put our rod through again. And we're going to lift the collective lever up. And it should stay exactly where you put it. And it does. Perfect. So that's the spring we want for this collective lever system. And you can see now it's fully operational. The tongs aren't moving and the counterbalance is perfect. Now if I hold the force field gear to simulate the stepper motor engaging the mag brake, which is what I'm doing now, and the pilot goes to move the collective lever, you can see it's actually the collective lever force field unit now that he's fighting against, just like on the real aircraft. And he would press the trigger, which would release the stepper brake, and then he can move the whole unit up and down nice and easily. Once he lets go of the trigger like that, the mag brake or the stepper motor energizes and he's fighting the force trim. At the expo, most of the pilots said that they constantly, when they move the collective lever anyway, they constantly disengage the force trim on the collective lever. But it also means when you let go of that button, the collective lever stays in the exact position that you left it. Just got this single nut and washer to go back on, onto the balance beam at the back here. That is the first video of 3. That's the collective build fully done and exactly how it should operate. Video 2 is going to be the cyclic build, and video 3 will be the wiring to the Arduino and programming, which is exceptionally easy. And that is it, guys. That is the collective lever fully built. It has to be one of my most favourite builds, partially because I've always wanted a helicopter control. And, you know, I've been doing the 737, but as a helicopter engineer myself, I had a good idea how it works. I just needed to put it into practice. And this started in my workshop in Brunei. Gosh, it must be 5-6 years ago, with a real 139 pilot called Rupert Kale. And he guided me through how it should feel, what it should do for the 139. So I built it on the 212 and then we adapted it to produce the 139 system. The base is designed to be bolted down to the floor or to some kind of base. That's why there's holes in it, because to move the collective on the real aircraft and on this now, at the centre of the grip should approximately be between 8 and 10 pounds without any friction on. And we're getting pretty close to that. It's quite heavy. Of course, when the mag trim is on, it should lock off in any position. For a 3D printed unit that operates like the real aircraft, it's a simple build. That's why this video has been so in-depth, to help you guys get through it. Because if you build this and then you jump in the helicopter on the sim and you put it on hard level, that moment of achievement when you realise you can fly it and you can keep it in a semi-stable hover is a great feeling. That's it for this episode, guys. Until next time, sim out.